Alright, so to do that, we are going to look at our last term, which is negative 20. And we are going to write P over Q. So the word rational means it can be written as a fraction, so that's why we do that. So P just represents what's our possible numerators. The possible numerators are all of the factors of negative 20. Let's list them in order. What are they? 1. How about 2? Yes. 3, 4, 5, 6, 7, 8, 9, 10, and then we would go all the way to 20. So do you understand where I got those from? Then my possible denominators are the factor of the leading coefficient. So not so many there. That would just be 1, 4, 3. So that's where we start, because that's going to find or help us find which ones are real. Now that's technically not the list. Really the list, if I would put it all together, is all of these divided by 1 and then all of these divided by 3. But, so I'll write them out. I know, lots, huh? So now, when you're doing like your homework today, I'm going to just tell you to factor something. I'm not going to tell you to list them all out, but I'm showing you so you understand where do I find the real ones? It comes from this list. And then we look at the graph. So let's graph. We're going to check it with our list and see, hey, which ones of these look like they're 0? So we're not having to check how many of things are there up here. 24 things. It's plus or minus, right? All right, so let's take a look at that graph. Oh, you put it up while I fix this. I'm just fixing my calculator. Now, okay, so what are your guesses? Help me out here, guys. What's your guesses? You think this is negative 10 over 3? I think it's negative 4. I think it goes right through the line. But let's check. Let's go to the table setup. And I'm going to do table, and I'm going to type in negative 4, and sure enough, it's a 0. Okay, so here's what I'm going to do next. Do what again? When you go to table set, you just have to make sure that only the independent is set as asked, because then you can type in what you want. What does the other one look like to you? Well, it's got to be something between 0 and 1, so either it's 1/3 or 2/3, and let's check 1/3. And yes, it is a 0. It says Oh, it does. Earlier it said that. So what are the real ones? They are x equals -4 and x equals 1/3. Okay, so let's go back. How many complex zeros does this equation have? 4. How many did we find were real? 2. So I have I'm going to be able to write 2 of my factors, which tells us how many are non-real. 2. So we're going to go through how to find those as well. So now, part C. How do I go about writing the linear factorization? Thank you. The first thing we need to do is we are going to get down to a quadratic. Okay, so if I have a degree 4, I'm going to have to divide off 2 linears to get to a quadratic. By the way, here's how some people say, well, I don't know, how do I remember factoring and then what to do? So factoring is reversing multiplication, correct? What else have you studied in math that reverses multiplication? Division. Okay, so if I tell you to factor something, we're going to find the real ones and then we're going to divide. It does not matter which one you start with. What would you like to start with? You're going to start with the easy one. Okay. So I put the -4 in the box. By the way, I know 2 of my factors. They are x plus 4 and x minus 1/3. I already know 2. I'm trying to find the other 2 now, and they're imaginary. So I'm showing you how to do that. And then I write down the coefficients, and I'm going to do synthetic division, and I better get a remainder of 0. All right, we get a 3. You might need your calculator out, I don't know. Then we get a, not yet, I hope. What's -4 times -13? Positive 52. -33 plus 52. 19. -76. -5. 0. Okay. So I just did a degree 4 divided by degree 1. If I were to write this out, this would be a degree 3. But I have another 0, correct? So now I'm going to do synthetic division again. What's my other 0? 1/3. So now I put 1/3 in the box, and I use my cubic polynomial, the one I just got. Don't bother putting the x cubes and stuff back in. And we're going to do synthetic division again. Alright, so now this actually ends up working out nicely. What's 3 times 1/3? 1. -13 plus 1? -12. What's -12 times 1/3? -4. What's 19 plus -4? 15, and 15 times 1/3 is remainder of 0. Okay, so I do not have the linear factors yet, but here's what I do have. So far, I have x plus 4. Are you getting where I'm getting that from? I have x minus 1/3, which I'm going to write as 3x minus 1. And then I have 3x squared minus 12x plus 15. And it's not linear because this isn't an x and an x. However, we called this something yesterday. Does anybody remember what we called this? A product of linear and, do you remember the word I used with this? Irreducible quadratic. Now, this is significant because today, on some of the problems, I only ask you to factor to an irreducible quadratic. So if I ask for that, then you stop. Okay? As long as you get to a quadratic. By the way, if it's a cubing function, you'd only have to divide once to get to a quadratic. Because it was degree 4, I had to divide twice. All right, so make sure you make some kind of a note of that in your notes, because I want you to understand that I'm showing you all the possibilities today, and that is a possibility today. All right. So, what or how do I get imaginary linear factors? The only way is using quadratic formula. And so we have to have a quadratic for quadratic formula. So we're going to run that through quadratic formula, and we're going to get 2 linear factors, and then I will be done. So to make my life easier, I am going to factor something out first. You don't have to do this. You still get the same reduction. What could I factor out of my irreducible quadratic? Nice. Okay. So I have x plus 4, 3x minus 1. I'm going to have linear factors in a second. And to get them, I am going to take my quadratic, and I'm going to factor out a 3. X squared. Ooh, what does that become? Okay. By the way, I'm going to put that 3 just up here. Okay. Because it's a factor. All right. Now, we're going to run this through quad formula. Remember our little song? X equals negative 3 plus or minus square root. Sound you familiar? B squared minus 4. Alright, x equals negative b. So what do I write first? Positive 4. Plus or minus square root. B squared minus 4ac. So I write negative 4 squared. It's going to be positive. Minus 4 times a times b. Okay, you're kind of quiet out there. Are you following what I'm doing? Okay, then all over what? 2 times 1. All right, so this is 16 minus 20. 16 minus 20 is good. Now, in Algebra 1, we'd say, can't do it. Square root of a negative number. But now we say, ooh, we can do that. How could I write the square root of negative 4 as what? 2i. So I have 4 plus or minus 2i over 2. And Sadie, you're saying what? Can I divide those both by 2? Yeah, that's 2 plus or minus I. So now I have my 2 linear factors. How do I write them as factors? It might look a little weird at first too, but you write them the same way as you write real factors. We would say x minus the 0, right? We're going to write x minus, and in parentheses, I'm going to write 2 plus I, that would be one of them, and x minus parentheses, what would the second one be? 2 minus I. Okay, so now if you want to be extra special and get rid of that, distribute that negative, go for it. It's not necessary. You don't have to. So this now is the linear factorization, because they're all x's, x, 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 x. Okay, so when we're doing linear factorization, are you going to see imaginary numbers? Yes. When we do linear and irreducible quadratic, are you going to see imaginary numbers? No. And a linear and irreducible quadratic always has to come before that. That's why it's kind of sometimes in our book, I feel like it's backwards, because our book actually teaches you to do this first, and then that, and to me that doesn't make any sense. You'll even see that in the assignment. They ask some questions about this, and then next, then they ask questions about that. So, all right, because we have time,